Hi everyone, welcome to Coding Bytes. Today I'm going to do a series on object-oriented programming patterns. First one I'm going to start with is the visitor pattern. Now, the way I'm going to describe patterns, I feel there's a lot of tutorials out there that go through the standard, the typical, whether they'll apply it to animals, they'll apply it to things that don't necessarily apply to industry. So hopefully, with their information coupled with some of my videos, some of these patterns will start to gel for you. Highly recommend learning object-oriented design patterns, because what you'll find is as you go through your OOP career, you will find you've been writing things and you don't realise you've already come across a pattern. And patterns are out there just to solve problems. There's a similar set of problems you're always going to hit, and these patterns exist to solve problems. Learn them, make sure you're aware of them, and you'll realise that you may even have been doing it in your code base anyway without even knowing it. The other nice thing about a pattern, if I was to say to someone now, oh, by the way, I've implemented the visitor pattern in some of my code, that's one less thing for the engineer to worry about. It means that they can look at my code, because I've used very similar naming, or I've used the naming of a pattern, they automatically know what that part of code will do. That's just one of those benefits as well you get from gaining a pattern. Not only do they solve a problem, they also convey meaning as well, because they're a common pattern. People go, perfect, visitor pattern, I know what you're trying to do with this. So, visitor pattern, probably, as it's one of the more simpler patterns to implement, yet probably one of the more complex to get your head around. But once you do, it will click and you can use it all day, every day. So first off, just on Wikipedia, what is the visitor pattern? In object-oriented programming software engineering, the visitor design pattern is a way of separating an algorithm from an object structure on which it operates. A practical result of this separation is the ability to add new operations to an existing object structures without modifying the structure. That's a bit complex at the end of the day. So I do find this, when you first run headlong into a pattern, it takes just a little while to work out what they mean by that, because it's not typically obvious. It's really not obvious. So what I'm going to do, I'm going to show you some code, and I've pre-written it. Originally I started this video where I was writing this code, and actually I spent the best part of a quarter of an hour writing some code, thinking about how we're going to use it. To be honest, you don't need to see this. What I'll do is I'll quickly run through the code that I've got and show you the problem I'm starting to run into and how the visitor pattern will solve this problem. And to be honest, it was the right way to write the code in the first place using the visitor pattern. We should never have written it the other way. What I have, I'm going to do this example. I'm going to say that I've got an object of a module. Now, that module could be doing anything. At the end of the day, it's a bit of a base class, because you might expect modules to be extended from and do a little bit more. But at the moment, I'm just going to say I've got a class called module. And at the moment, one of the main things it does is it allows me to give the module a name. So that's what you can see here. In feed, process, and out feed modules, I'm just passing in a name. Now, in the constructor, again, it's not technically a constructor, FB init, just be wary of that. It's not a true constructor. It operates slightly different from inherited from methods anyway. But anyway, that will be another video. There's definitely more to it. Anytime I pass in a name, I save the name internally in its own internal variable, just there, max string. And when I get the name using a property, I just return the name. So that's the first part. I use the underscore notation. Anytime you've got a property that matches a variable, that's not possible. It can't work out who you're talking about. So I typically use, I believe it's a .NET style of naming, that if any time my internal variables or my local variables clash with a public property, I put an underscore. It's just a convention. So yeah, because quite often name, I mean, what else do you want to write as a variable name there? It's name, underscore name, it's just as easy to understand. So so this thing has a name. The other thing as well, just so I could give it a little bit of context and a little bit of flavour, what I've done is said that my modules are allowed to have they have an error, and I can ask upon them what was their last error message. So these things here, and that's going to be a method called setError. So, and this just allows me to trigger this. It just allows me to have one of my things to have an error, and you can see that in here. So if the code's not been initialized, got a little bug there. It would have just kept it. Not that it would have really mattered, but let's just set it to false. Sorry, set that to true. There we go. Nice. So if the code's not been initialized, then what it does is it actually just sets an error on this infeed module. So it passes in the string of the error. And again, this isn't the visitor pattern yet. This is just me setting up something we can use. And modules is quite a typical thing you might be making. So I'm calling this method of setError. I make the last error message equal the message that I've just passed in, and hasError becomes true. So now if someone was to say hasError as a property, that says true or false. And I've also done it as a method, get last error message, only to prove that this doesn't just work, the visitor pattern won't just work on properties, it will work on methods too. So I could have just had last error message as a property, and we just say, hey, can you give me your last error message? I've done it as a method. So when you say get last error message, what happens is I return the last error message. So that is my mock-up of my object, and it just allows me to just have 3 modules. One of them's got an error, which I can inquire and I can check. Now, this is the bit of code that is sitting in the wrong place, and this may be code you have written. Let's say, for example, the requirement was of your modules that you should be able to pass it a string and ask it to add its status to that string. Quite a valid thing. Ultimately, you might pass it something like a JSON builder, or you might pass it XML. In this instance, I've said, I'm going to give you a string, and which is represented by string log, and it's just a reference to a string, which means that any time I write to it, the real string, the one in main, gets edited. I'm saying, please add your status to the string log. And this is the code that's currently living in the module. Now, just talking you through what this code is doing, it adds an open square brace, it adds the name, it just pulls that straight from the name, and it closes a brace, and then it checks, and it says if the module has an error, then it writes colon has error, then it gets the last error message, and then puts a full stop and a space. Otherwise, it says has no error, and then leaves a space, and that's it. So when we run this program, we'll actually see it log in with downloads, just so it all nicely restarts. We'll see that I'm initializing the module. I'm initializing the code. So it means, in other words, I've set the infeed module to have an error. And what I'm doing is saying for each one of my modules, can you add your status to the string log? And I pass in status. Status is max string. And you can see what's been returned. So this is as expected. Infeed has got an error of infeed jam. That's valid. That's exactly what I've asked it to do. The process has no error and outfeed has no error. Totally valid code. There we go. So hopefully that's set our example code. This is the code we're going to work with now. And we're going to look to say, well, that's valid code. Where does the visitor even come into? Why would we even need a visitor? And how do we implement a visitor? So the problem, the one that we then run headlong into, let's say the customer turns around or your end user says, oh, that's great. Love that status you returned. But we've also got another system that wants to know that status too, but it doesn't like square brackets, and it prefers to have I don't know, maybe question marks, maybe something along those lines. It's a different style, and they say, oh, can you also produce a log that does this? Now you kind of think to yourself, I could add these to the input of this argument and say, well, what should you use here instead? Should I use open and close braces, or should I use question marks? Danger. We're already getting into the point where that's pretty dangerous, because now we've got a method that can potentially do a bit more than what it should have done in the first place. So we're already getting into a bit grey territory anyway. And that would only work if that's the only change that we're going to make. Other solutions that you may see people doing is going, oh, okay, so, and let's say the status, that was actually going to be sent to the printer instead. Maybe you would then be tempted to say, well, add status to string log for printer. that type of thing. And maybe we just make a brand new method and we say, yeah, okay, all right, I can deal with that. This one's for the string log for just what was originally, and this method is one for the printer. And the printer must have question marks instead. And hopefully you can see there was danger in that. Two requests of things that this thing should do has caused two methods to be made on an object. This object, I mean, if we take the solid principle, and it, at the end of the day, is breaking S already. Solid, single responsibility is the S of solid. Our module class is not just our module anymore. It's a class that knows how to make a response for a logger, and it also knows how to make a response for a printer. So you could argue you're a module, a logger, and a printer logger. You've gained two other responsibilities. So you've broken S already. So you have also not implemented the O of solid, which is open for extension, closed for change. Every time that customer says, I've got a slightly different printer now, or let's say it's not even a printer. I want to implement IoT now with these, and I want to log this to IoT instead. Therefore, instead of this layout, can you produce this in XML for me? Now, suddenly we go into so add status to XML string, that type of thing. And don't get me wrong, I mean, you might have an XML parser that you just pass in and do all your good stuff. You may just say add the name, and it does it automatically for your XML. But hopefully you can see the problem is every time someone asks something new of this object, like as in a new thing it's allowed to do, it causes a ricochet effect on the object itself. The object has to do more to be able to do that job. If the customer turns around and says, I've got 1,000 different protocols this object must implement, you can now see that this is a problem. You've hit dry. You've got the same code over and over and over again. And now if we were to turn around and say, well, actually, no, we're going to change the way name is, we're going to rename name or something along those lines, every single one of these methods is going to have to change. We're already into this world of change at the moment. So you can see that this style of work is wrong, and hence the reason we need to introduce a pattern. The pattern that we will introduce is the visitor pattern. And this is where I'll try and keep referring it back to how they've written it. So what they're saying here, the visitor design pattern is a way of separating an algorithm. This is an algorithm here. So adding the string to a log, adding the string to a log for a printer, adding to XML string, that's an algorithm. And what we're doing is it's a way of separating that algorithm from an object structure on which it operates. Now, these were embedded in the module. So the visitor pattern is saying that if you apply me, I will allow you to take that algorithm out of the object and keep it somewhere separate. And that separate thing is a good thing, because that means that if I separate it, the thing I've separated has one responsibility, and its responsibility is to give me the log string for a printer. That's it. And the module should not know about that. It should be blissfully unaware that someone has made a printer's log string. So there we go. So let me show you how we implement it. What we do instead is, well, one thing just to prove, all of these methods here, sorry, it's going to get a little bit noisy. All of these methods here, they only access the object using properties and methods that are available on the object itself. That's one of the key things first. It's not accessing anything truly internal, because visitors, when we start implementing the visitor pattern, the visitor is only allowed really to speak to the object at a safe level. It's allowed to speak to the outside of an object. It's not allowed to know, just the same way as all objects, you shouldn't know what goes on inside an object. That's the whole reason for encapsulation at the end of the day. So these things here, we're managing to do all this by using these properties and methods ultimately. So what I'm going to do, let's get this written, otherwise I'm going to end up with a really long video. So what I'm going to do is I'm going to call this, we'll do the one for the, well, let's just do any of them. I'm going to call this my status to string log visitor. So the job of this thing, this visitor, is to make this out of a module. But the module not to do it, it's the visitor that's going to do it. So what I'm going to do, I'm just going to copy this out. Let's have a think as well, because we also need to obviously pass in the string. I don't want to cloud this example too much with things that happen behind the scenes, but yeah, at the end of the day, the visitor. So I'm going to make a visitor, and I'm going to start writing, and then I'll keep explaining what I'm doing. The visitor itself, that's the one that's going to be in charge of saying, "Hey, visitor, here's a string, here's a destination I want you to write it into. Now do your thing. You're going to do the job of collecting all the strings, forming up all this data, but ultimately this object needs to know where it's going to put it. So I'm going to make a constructor as well. Constructor. Oops, let's call that correct. And its constructor, we will say, sorry, it's FB init. And you'll see why I'm doing this in a minute. So this thing, because in just the same way as when we called these, we had to pass in where do we want it to be written. I need to tell the visitor, yeah, I mean, you're responsible for doing this job. Where are you going to put this information? So I'm actually going to pass that in at the start when I create the visitor. I don't need to. I could do that at a different time, but I'm going to do that when I instantiate it. So, and also as well, I need to save that because obviously that's being passed in as constructor. So this is going to be my, what do we call it? That was string log. So I'm going to call it the same thing because may as well. There's no need to. There's no properties down here called the same thing. It's a reference to, and because they're both called the same, because that's called string log and that's called string log, you have to use the this hat dot in order to know who I'm talking to. That's it. Had I have called that something different, if I'd called that string log 23, I could have used string log 23 here equals string log. The compiler would have understood who I'm talking to. But because they're called the same name, I have to be explicit with who I'm talking to, and therefore I can force it to say use your local variable instead. So that's just a little side thing. So the other one as well, because I'm using a reference, I have to use ref equals. So again, I don't want to cloud this with what is a reference, what is all these things. This is, at the end of the day, this is a video about a visitor. So let's just quickly get over this part. Okay, so at the point when I've made this, I'm currently holding a reference to where I want to write this string, ultimately. Now, the visitor pattern, what it is we're going to make a visitor who will visit a module, and then that visitor will be able to pick and pull anything it likes from the module it visits. Now, the way around that's going to go is we're going to need to use some interfaces for this one. So interfaces, I do cover this on previous videos, which is my introduction to OOP. Again, I will talk while we implement this, just so we've got in mind what this is, but you need to use interfaces. A lot of design patterns of object-oriented programming use interfaces for this reason. You can use classes and inheritance to do it, but by far, use interfaces all the way. So I'm going to make a few interfaces at the moment. So the first one I'm going to make is an iVisit modules. So that's my first one. Oh, sorry, that's a method there. Sorry, let's just do that properly. Interface. So I need an interface of iVisit modules. That's it. And I need another interface which is I could write I am a module or I module at the end of the day. So so the first things first, this module I'm going to expose what I'm going to do is I'm going to make it available all of the properties and methods that someone's allowed to call via an interface. So I'm just going to say implements, and spell implements right. I module. Okay, so it's going to implement I module, and that just means that because I'm a module, I don't need the set error. I'm going to say these three things here are accessible. So if someone speaks to me as an I module, they will see these three things. The iVisit modules, that is going to be someone who has the ability to have a method on it called visit module, And we'll implement this and then we'll run through it. This is why the visitor pattern, it's a very small pattern and it's a little bit tricky to describe, but you'll see it in the end. So if I'm a visitor, a module visitor, I have to have a method called visit module, and we don't return anything. And visit module must take a module. Again, you can kind of call this what you'd like at the end of the day, but yeah, personally I'd just call it module, and it's an I module. We'll see how this all ties together. My visitor is implements an I module visitor. MOD ULA visitor. Let's just make sure I spelled that right. Sorry. Oops. I visit modules. You could, yeah, I visit modules. I module visitor, either. Again, there's no real convention. There is a convention, but yeah, it all follows this thing. The visit is the convention, and because it implements this method, this interface, it means it must have this method, and we're just going to paste that method in here, which means a module will call it and say, I am the module you're visiting. We'll implement the last thing, and then I'll show you the final tie together. And the thing that will be visited needs to have the method called accept. So accept, it doesn't return anything, it's public. And if I open this one here, and it has a visitor, which is an I visit modules. Oops. Okay. And the final thing I'm going to do, just so I can get rid of some of this, I'm just going to copy all of this code here. So anything that was this add status to string log, I'm just going to copy and paste it in here for the moment. It's obviously not going to work, but just to get it out of the way, because what I want to do is just delete all of these, just to prove that we don't need them anymore. The code that goes inside accept, all we do is say visitor.visit module this. That's the only thing you'll find inside an accept method. So when someone visits the module, so module.accept, and you pass the visitor in, what actually happens is the visitor comes in here, and we call upon it.visit module and pass ourselves back. So it's kind of, if you think of it, I've visited the module, and all the module has done is said, hey, hi visitor, visit me. Like, as in visit module, me, and me is this in our language. And so therefore, at that point, the visitor will have this method called, and the module will be the module it's currently visiting. And now we can start accessing parts of it. So this module here, we can say, module.name, and we can say module.getLastErrorMessage and module.hasError. I mean, that's all valid code now. Let's just save that. The other thing as well, I just need to slightly tweak. I'm just going to make it lowercase, just because it is lowercase now. So string logs. Let's just make up. I could do a find and replace. You're all shouting at me for doing this, but it's just as quick. Well, it's not just as quick, don't get me wrong. That was much slower than doing a find and replace, but still. Okay, didn't need to do that because it's not case sensitive, but at least it shows I'm using the local variable. So what we've got here, that's our visitor. That's our module with accept. And let's just see how we now change, the code to use the visitor instead. So we don't have these methods anymore. These methods don't exist. What we do, however, have is a visitor that will do the job for us. So our visitor was called status to string log visitor. We're almost at the end now. So this will all start tying together. And remember, we have to provide it when we construct it. We need to provide it where we want the string to be placed. So just back in main, we want to write it into status. That's where we're going to write it. So, and let's just got lowercase. Nice. Now, instead of doing all of these, what we do is we say dot accept our visitor. That's it. And we'll just copy and paste that instead. Done. And done. Save. Right. I think probably what's going to be best first is let's just see if this works, and then we can explain why it's working. Because hopefully some of you following along at the moment will start seeing that this should work, as long as I've not done any crazy errors. This should start working. So if we just open up main and here, it's totally worked. We've pulled the mechanism of creating this log string. I mean, that's just an example, but we've pulled that algorithm out of the object and we've given it to someone who visits the object instead. Because now, if we were to turn around and say, no, we need that printable one as well. So let's just say that this is our normal status. This is the status for printer. We can now make a new visitor. And we'll do status string log visitor. So status string log printer visitor. We can copy and paste this. Let's just call that the same thing as this. And just that one here. Just paste that. Status string log visitor. And we'll just refactor. Done. And its visit module, instead, it uses the question marks, like we said before. We said, no. A printer, we use question marks instead. And if we go into main now, maybe we want to, let's just do the whole thing again. Let's just do this instead. And this time, we're going to do to the printer instead. On here. And log in with download. Play. Status for printer. Why does that one not work? Sorry, that's because it did work, but I wrote it to the wrong string. Let's put it into the string for the printer. Play. There we go. Right, so we can now see that we're getting two completely different strings set up because actually that's just going to get longer and longer because I'm not resetting it. Let me just reset it as well, just so we've got something plain, and then I'll speak through it. That's it. Let's just do that one there. Again, live coding. Coding Bytes, hey. And hit play. Okay, so we can see the two different things now. So, yes, code still exists. We needed to write the code for making the status for the standard log, and we needed to write the code to make the status for a printer. But in the past, we were putting it in the object. We were forcing the object to implement that, and therefore every time we added something, our object needed to change, our module object needed to change, and therefore, and plus as well, its single responsibility was completely broken at that point. This module at the moment here is just doing everything that a module should do, nothing else. There's nothing else it should do. A module looks after its name, it can have errors, that type of thing. It's not worried about making a log file for a printer. It's not worried about doing something else. If suddenly we turn around and say we need to log other things, it's not worried about that. It doesn't need to concern itself. It just needs to accept a visitor, and the visitor needs to know how to do those things. So that's sort of going full circle. Visitor pattern, separating an algorithm from an object structure of which it operates. That's exactly it. So we've developed I accept someone, and that person that I'm accepting must be a visitor of my type. So we've said we've got an iVisitModules visitor, and that's the type of visitor I'm going to allow myself into, because let's just go offline, I'm going to accept someone who visits modules, iVisitModules. So welcome. But anyone who is an iVisitModules must implement the method of visitModule, because I'm going to call myself. I'm going to say, hey, visitor, visit me. Because you're visiting me, I'm going to inverse the call. I'm going to say, right, well, your time to shine. You're the visitor. You are visiting me. And therefore, it pops back the other way around. Module now contains the module that you're currently visiting as an iModule. I mean, you could have done it as a reference to a module instead. But personally, I tend to program to interfaces. So you could have passed a reference to module at that point. That would have been completely fine. That's not an issue. But program to interfaces, you may as well. And at that point there, it's up to it what it does. I mean, let's say, for example, we said, no, maybe, I mean, let's just say this one as well. Maybe the customer says, we would like one that only logs modules that do not have, or let's say, for example, this printer version. Maybe they turn around and say, oh, no, we made a mistake. We only want to log things that are not in error, or maybe that are in error. Well, then that's just this one down here that's changing. So we could say that, oh, okay, if we're not worrying about anyone that has an error, then we'll just return straight out, return. But if you don't have an error, then we'll just get rid of that. We'll just write your name instead. So let's just do this one instead and just see how this one changes. I will download. So you can now see how your visitors may be things that know how to query things. Maybe you say, I only want to know error messages from modules that have got the capital letter A at the start of their name. That's completely fine. It's because your visitor is doing that. Your module is not. You've deferred that process. So there we go. So that visitor now, status for printer, it's a visitor that makes a status for any modules that do not have an error. Now we've done this whole thing on logging of status. The visitor is allowed to do anything to the module that is exposed to it via that interface. So via that iModule interface, the visitor has gained an iModule. The fact that it's taking data from it, that's what we've asked it to do. We may have a visitor that visits and updates settings, or it might delete an object, or it might do something with it. It might interrogate the object and ask for other objects that it passes to other visitors, that type of thing as well. So just bear in mind, the fact that we've used it to pull data out of something, and we've used the example of creating a log for a printer, maybe we create a log to go to IoT, that's very creational. We're using it to extract data from something without the something even knowing that that's occurring. We could have done things like set the error message on it, set this, delete, add new parts, update settings, that type of thing as well. Again, it's a way of adding functionality to a module using its exposed properties and methods, and just having something, a nice place to contain that code. The algorithm is now here. So this algorithm, this visitor, its sole purpose in life is to create a string log for a printer when it visits a module. That's it. It's got a single responsibility. That's a perfect thing. It's the perfect place to put that code. We can have as many as we like, and we can all visit that module as much as we like, and everyone works together. And I think that's it. Let me know if you'd like this expanded. A visitor itself could visit other things. If we were to say, I did mention before that I might do this for a sensor as well. All that would occur is if I wanted to visit something else, let's just cancel this off. You would have another interface of iVisit sensors, for example. We'll just OK that, and the method would be visit sensor. I'm not going to automatically rename it, otherwise it might rename all these. There we go. So potentially, if I've got something that implements an iSensor and it visits a sensor, then here's sensor. And this thing is an iSensor. There's nothing to stop me saying that this visitor doesn't necessarily need to only attach to a single thing. Because let's say, for example, okay, you might say, well, that breaks single responsibility, but it's not. The single responsibility of this thing might be collect the status of all the things our machine contains. And a machine may contain modules, it may contain sensors, it may contain all sorts of stuff. So the visitor's allowed to do that. It still has one reason to exist. It collects the status for a printer off of all of these different modules. That's completely fine. If I wanted to modify this code so this thing could visit a sensor at the same time, not at the same time, but as well, all you do is just say it also implements iVisit sensors. And as soon as I do this, it says, well, if you visit sensors, you must implement the right method to visit a sensor, and which means we have to copy and paste this one across. In here, we would do a very similar thing. I mean, at the end of the day, what do we want to do when we visit a sensor? Do we just want to get its name? I mean, maybe. I mean, well, we're so close to actually finishing the extra example. Let's just take this and just say sensor. We'll just do sensor name is equal to. Just do that. Maybe that's what it does when it's visiting a sensor. Sensor will have a name, and then it's very, very quickly just make a sensor. So I'm just going to copy and paste the module. We'll call this one sensor. It's not going to have any of the has name, error messages, anything like that. We don't need that in this one. We've already proved an example of this. The constructor does have a name. Name is still the same, and we'll just remove those as well. Because again, I'm going to make this available on GitHub so you can use it. A sensor implements iSensor, and save. And the last thing we need to do is make the iSensor interface. So iSensor, and anyone who's a sensor has a name. That's it. That's the only thing it has to implement. Good. Let's power that up. So we're going to have a jam sensor, and its type sensor, and its name is jam outfeed jam. Jam blocked again. That's what jam means in my sense of the word. And so jam sensor, and what we can do is say jam sensor accept. You're going to accept someone, and we've already made status to string log printer visitor compatible, so it can be visited by that as well. That's completely valid. Let's just make sure it's correct. So when it visits a sensor, all it's going to do is write sensor name to it, and yeah, everything should be good. That should be enough. Login and download, just so it's nice and clear. Oh, we got an error. There we go. Can't convert. There we go. Sorry, that's me. That's my copy paste for you. So the sensor itself, it needs to accept someone who is iVisit sensors, and therefore the visitor will call visit sensor on the person that's been called in. So that's that wraparound. Anytime, I mean, what a handy method to implement on an object. If you think, I mean, why not implement an accept method every time? Except I accept someone who visits sensors, and I pass myself back out as an iSensor. There we go. You've just made your object. Anyone can now use your object using a visitor, because you don't know when someone will want that functionality. So maybe just bake in the visitor pattern automatically. Just add an accept method in there. So well worthwhile. But let's just save. Log in with download. And then play. Main. And there we go. So you can see here that our status for printer now contains process, outfeed, and sense name of outfeed jam. So one object which is the visitor, it's visiting two separate things, and it itself has two separate algorithms for if it visits a module or if it visits a sensor. Perfect. We've decoupled all of that algorithm from any of these. Neither module nor sensor know or care about who is visiting it. And that's it. Okay, I hope you enjoyed that video. I hope that has added something to the visitor pattern for you and your understanding. Obviously, there's a lot of other videos out there. Christopher Akravi, I highly recommend listening to him for object-oriented design patterns. And I'll see you in the next video.